I'm just gonna continue today, and I think I found a better direction than the one that I was thinking about doing last time. It's kind of on the same lines, I think, on the one that I was thinking about, but is slightly different. And one thing that I remember is that I can use the debugger on VS Code to help me study. And I think the reason why I was avoiding doing that in the beginning is because I thought that it might be hard to set up because remember on C and C++, I had a very hard time figuring out how to set up the configuration. But this one looks like the first one was worked. It's basically this one that GPT recommended. So that's great. I think I'm gonna use that. So for this project, currently I'm going to use that for sure. But I'm thinking about going over the libraries, and then instead of manually looking into the code, I try to first build them and then I go over with the debugger. I think that's probably much better. And the extension you need to make the debugger work is this code LLDB. I'm going to listen again to the GPT's answer or last prompt, then I'm gonna step over with the debugger on the current code that I have. Basically, the idea that I'm trying to do now is to extract the patterns from the libraries that I have there. So I asked GPT for a prompt, then I sent to DeepSeek, and DeepSeek created the start of this project that I'm gonna debug now, or go over with the debugger. And what this project basically does is go over the libraries that I have there, and it extracts the patterns of what other libraries are used the most. And then the next version 2 that I'm gonna try to have the agent do right away is gonna be to implement or to extract more patterns around the syntaxes, and basically build a frequency list. Because that way, obviously, I know what patterns are used most of the time. Then based off that, I'm going to create a list of, I'm going to manually create a list of exercises, because that way I already train myself building them. And then I'm going to take whatever is used the most on to the website, to the Rust quiz website that I have there. I'm just gonna listen to the response here, and then I'm gonna start going over with the debugger.
Yes, this is a good result. More importantly, it has already clarified what the next stage needs to be. I would now think of the project as a pipeline. Real Rust corpus libraries _underscore study census v1. External ecosystem dependency census v2 Rust language source patterns pattern map transformation structures type mechanisms wiring manual labs tiny. Programs you implement debug modify Rust forge extract pure memorization facts. We're only at the first box of measurement. I would not start generating exercises from this dependency table alone. What the census just established, the corpus is already substantial. It found 1,593 cargo manifests, classified 1,210 as counted workspace. Packages in 383 as non-workspace manifests, with 0 parse failures. The size disparity between repositories is enormous. Rust 354 manifests said 241 0 copy 172 MC 154 wasm time. 102 burn 59 track 59 wasm byte 57, while many projects have only 1 or 2 manifests. That validates our earlier decision to use repositories containing X as the primary statistic rather than raw manifest counts. Otherwise Z, Rust, MC, and similar giant workspaces would completely distort the curriculum. The first ecosystem patterns are already visible. The current top dependencies are 30 38 repos ran 28 30 underscore JSO and 25 lib 23 criterion 22 anyhow 20 log 20 clap 20 temp file 20 number trace 19. Rayon 19 code 19 PROC macro 2 19 Tokyo 18 18 futures 17 0 16 wasm byte 14 tracing 14 regex 14. Iter tools 13 tracing subscriber 13. This is already telling us something interesting. It's not a random list. There are recognizable Rust wiring families. Data boundaries 30 30 underscore JSON 30 appearing in 38 repositories. About 2/3 of the current corpus is a very strong signal. So eventually you absolutely want a tiny canonical pattern for Rust type up down arrow serialized representation including Rust derived serialize, deserialize 30 underscore JSO and from underscore str. 30 underscore JSO and underscore string, and later board slash custom serialization. Application shell clap. Anyhow, this error log tracing subscriber. This is exactly the category you were describing before. A real Rust program repeatedly needs CLI errors logging tracing configuration startup shutdown clap. Anyhow, and log each appear in 20 of the scanned repository directories, while this error appears in 16 and tracing. In 14. So this should eventually become one of your wiring capsules. ARTS downward arrow clap downward arrow type config downward arrow run downward arrow result downward arrow anyhow type error downward arrow diagnostic exit. This is precisely the sort of boilerplate knowledge you want available without searching documentation. Async slash concurrency rayon Tokyo futures parking underscore lot portable atomic rayon appears in 19 repositories. Tokyo in 18 futures in 17. That's a strong signal that your eventual core curriculum needs separate patterns for serial iterator downward arrow parallel iterator function downward arrow future downward arrow runtime execution shared state downward arrow synchronization. Procedural macro ecosystem. This cluster is extremely obvious. Quote 19 PROC macro 2 19 18. That's almost a perfect empirical example of a recurring library bundle. Later you should have a capsule. Rust tokens downward arrows and downward arrow AST transformation downward arrow quote. Token stream not necessarily early in your learning priority, but we now know this architecture recurs heavily across serious Rust libraries. Browser slash WASM wasm byte 14 JS SYS 11 web SYS 9 wasm byte futures 9. This is particularly important for your browser work. It gives us an empirical stack. Rust downward arrow wasm byte downward arrow JS SYS web SYS downward arrow browser instead of treating all WASM creates as unrelated things. Numerical work the census already shows. Number trace 19 rayon 19 half 9 number complex 9 and array 8 that aligns very closely with your intended ML slash ESP slash scientific work. But there's an important distinction in the numbers. Look at criterion. 22 repositories, 42 packages normal, 6 dev, 36. That's not saying. Criterion is one of the most important runtime libraries in Rust. It's saying performance benchmarking infrastructure is extremely common among the kind of serious libraries in your corpus. Similarly, temp file has substantial dev usage. So we should stop thinking about one universal frequency number. The census is really exposing several ecosystems. Runtime 30 clap Tokyo Rayon. Development criterion temp file prop test try build quick check. Build macros in code PROC macro 2. Platform lib CFG portable atomic. This will eventually produce different training priorities. Before census v2, I would fix two things. One, don't count non-Rust directories in the denominator. Docs is currently counted as one of the 57 repositories despite having 0 manifest 0 packages, so all percentages are slightly understated. I keep docs in an inventory, ignore directory report, but not in. Scan underscore rust underscore repositories. The frequency denominator should be repositories that actually contain at least one relevant cargo package. Small issue, easy fix. Two separate external dependencies from workspace internal dependencies. This is more important. For example, the crane result contains crane core alongside Surdy Tokyo candle core. And Symphonia similarly contains its own internal packages. Symphonia core, Symphonia code, Symphonia format tog. Those dependencies are useful information, but they answer a different question. How does this repository structure its internal crate graph? Not which ecosystem libraries are broadly reused. So census should produce external underscore dependencies, internal underscore workspace underscore dependencies separately. That internal graph will actually become interesting later when studying architecture decomposition, but it shouldn't contaminate your external library ranking. The current parser doesn't appear to retain the package's own package.name. It currently records whether package exists plus dependencies and workspace metadata. So v1.1 should add rust package underscore name option string, then for each top level repository, internal underscore package underscore names all counted workspace packages dependency names set membership symbol internal underscore package underscore names right word arrow internal. Otherwise right word arrow external symbol. One smaller edge case the current handling of TOML dependency Surdy workspace true directly counts Surdy. But suppose the workspace root contains TOML workspace dependencies foo package actual crate version, and the package contains TOML foo. Workspace true the current package parser will see only the local key foo. It doesn't currently resolve inherited package renaming against workspace. Dependencies. Its normalization falls back to the local key unless that particular dependency table itself contains package. That's probably rare, but since this is supposed to become our measurement foundation, I added it to v1.1 rather than forgetting about it. I would also produce 4 rankings instead of 1 after those fixes. Generate external underscore runtime underscore dependencies.md external underscore dev underscore dependencies. MD external underscore build underscore dependencies.md internal underscore workspace underscore dependencies.md plus the current combined report. Then the reports answer distinct questions. Runtime what crates do Rust programs actually ship using? Development what tooling patterns recur while developing serious Rust libraries? Build what build slash PRC macro infrastructure repeatedly appears. Internal how do large Rust projects decompose themselves into crates? The fourth one could eventually be surprisingly useful. The code itself looks good to study with code LLB before asking the agent to change it. I would actually do one manual session now. Put breakpoints in this exact sequence. Main .rs run the bars run config .rs load underscore config repository .rs discover underscore repository census. Rs analyze underscore repository manifest .rs parse underscore manifest membership .rs resolve underscore membership census .rs combined report. Rs write underscore all the execution pipeline is extremely clean. Corpus .toml downward arrow discover repositories downward arrow discover cargo. Toml downward arrow parse manifest downward arrow resolve workspace membership downward arrow aggregate one repo downward arrow combine all repos downward arrow write reports that structure is directly visible in lib. Rs. I would spend maybe 15 to 20 minutes stepping through it. Particularly inspect rust manifest membership counted DEP underscore usage results. Dependency underscore stats. This is already a useful Rust exercise because it contains vec tb tree map b preset option result iterators map filter underscore map entry or underscore default ownership across functions file system path buff error. Propagation in other words, the tool we're building to discover patterns is itself already a pattern training example. That's useful. Then build census v2. This is the important next project. Census v1 answers which crates. Census v2 must answer what Rust itself is repeatedly doing. This is much closer to your core objective. I would initially produce these reports. Generated source types.md methods.md traits. MD macros.md language underscore constructs.md generic underscore constructs.md ownership underscore constructs.md we want data like types spec option results string hash map argbox rc mutex. Methods iterator underscore mut into underscore map collect filter filter underscore map get underscore mut insert entry clone as underscore ref as underscore mut take on wrap expect. Traits iterator from the from as ref ref clone default sensing. Language magic let while let closure. Async await unsafe. Generic t word trait dime trait associated type const generic hrtb. This is the census that will directly create the transformation curriculum. Don't try semantic resolution in census v2 yet if it sees rust x map foo just record method underscore name map do not initially try to prove iterator map option map result map that's census v3 territory if we even need it. Similarly, Rust arg new can be detected syntactically. The first question is simply which pieces of Rust syntax and API vocabulary appear everywhere. That is enough to drastically narrow the space. And then we stop measuring and start training once v2 exists. Take perhaps top 20 data structures types top 40 transformations methods top 15 traits top 15 generic type. Mechanisms top 10 wiring patterns not necessarily literally these numbers, but approximately. Then create labs transformations labs data underscore structures labs type underscore system labs wiring from the measured results. For example, suppose the data confirms vec option result iterator underscore mut into underscore map filter underscore map collect as underscore ref take entry those become weak one. You manually implement tiny direct transformations. Vec t downward arrow vec mut vec t downward arrow mutated in place vec t option t downward arrow option t iterator result t downward arrow result vec t no stories. No algorithms. No leak code wrappers. Just the transformation. Then add the type relations lab alongside it. I wouldn't wait until you've mastered all the methods. As soon as the first training corpus exists, begin tiny experiments around generic inference straight downs associated types method resolution coefficients auto direct lifetimes variance monomorphization because it answers. The other half of your problem, what code do people type? Why does Rust assign that code this meaning? Those should develop together. What this means for the overall project, I think we now have a much more defensible architecture than when we started. Originally we were contemplating build some exercises, now we're building something more systematic, real Rust empirical. Census libraries language architecture use patterns. Pattern graph understanding. Recall fluency lab Rust forge the big advantage is that you no longer need to guess. What do I need to memorize? The corpus tells us, and you don't have to trust one library author. Is this pattern actually common? The cross repository data tells us. And frequency doesn't become dogma because we can combine it later with frequency, strategic relevance, personal friction, conceptual leverage. So maybe it can still rank highly for you even if unwrap appears 200 times. More frequently, my exact next order I would do v census v1 manually step through census v1 with code LLB census v1.1 exclude zero manifestors from frequency denominator distinguish workspace internal vs external dependencies resolve workspace inherited renamed dependencies separate runtime dev build reports inspect the clean dependency results here census v2 source syntax type method trait census inspect census v2 here define pattern map v1 implement first 20 direct transformations manually implement first type relations experiments only then touch Rust forge I think. That's the shortest path from where you are now to actually beginning the daily training ritual while making sure the thing you're practicing is grounded in real Rust rather than arbitrary curriculum design.
So the great thing about the debugger on Rust is that it shows the assembly. That also can be a bad thing because it can lead me to spending a bunch of time focusing on stuff that doesn't matter that much, or practically speaking. So after you set up the VS Code launch.json here is gonna show up here, but you can press F5 and then it's just gonna run the default configuration you have here. In this case is this one. I want to try to step intro, which is F11 first. But then if it gets annoying, I'll just try to do F10 and then probably F5 to skip to the next breakpoint if there's just too many useless things. Obviously here I think is using this std env to get the current directory, then it's gonna find the corpus toml. I didn't know you can do this, but HTTP told me to create this file, then put this path here, and this is the path where I have the libraries that I want to study. It's basically this folder here. So I cloned a bunch of libraries, and like these are the ones that I'm most interested on studying now. So obviously, I imagine that it's going to loop over them, or it's going to loop over the folder probably, and then try to parse somehow. It uses this other one. I'm pressing F11, but it's not going. It's not going the functions, which is kind of weird. It's using 30, however you say that, to parse files, I think. So this is the code that I have there locally. Obviously, it's using a library here, but in this string library, I think. So this. Maybe we should write this down because it's very interesting. Sometimes the debugger on VS Code has these problems. I had this, like similar issues on when I was setting up for C and C++. That it says there is an error, but there isn't. And I think the problem is like on the message passing between the debugger and the VS Code adapter. I don't remember exactly how it works, but I do remember. So I have the UI, then there's something which is called debug adapter, I think, which is kind of like the bridge between the UI and the specific debugger you're gonna use. I think when they message back and forth, there can be some errors. I think that based on my experience with this, on when I was going over the Godot's source, from what I remember, like the main thing that I remember regretting initially is to go too slow in the beginning on each thing, because obviously you get like you spend too much time on things that don't matter that much. I think it's probably better to just use F10 now and like try to go as fast as possible through everything and just get a general sense of how everything works. So basically, obviously here is going to be the parsing logic. It already has the tokens based on this library that it uses here. And I think this is creating the abstract syntax tree maybe. Russian key. Yeah, so it just goes over the tokens and then builds the ASD from them, I think. Yeah, so the name of the library, I think it is the table here that is using. Don't understand how you can use this, given that there isn't anything on this file that is explicitly using this normal thing here. And didn't go into this. I think that it didn't go here because it's lazily, like the map doesn't run right away. So maybe it will go later. Yeah, I think that's going to the functioner. So it's calling the cargo tomo files as manifest files. Yeah, so I think that even though I don't know the specifics of what's happening, obviously based on the names, it's very easy to understand that it's just going over the directory and then exploring, like probably recursively exploring everything. All the subdirectories to find cargo tomo files and then pushing to this vector with the paths there. I think I can look into the value. So this name is docs. So I think that this function is gonna go, yeah, because it loops, it goes over inside of this on the map there. So the map contains all the main folders, and then each one does this search here, I think. for the cargo tunnels, and this one doesn't find anything because it's just the docs folder. And now this one is going to be the crane. Assume that there will be manifest. Reads the file. And uses the STOML again to get the value from the string. I wrote down other stuff here that I was planning on sending GPT as well. Because I was thinking about the order in which to do this. And since I realize now that I can use the debugger to go over the libraries, I think that makes more sense to so first finish doing the census project, then extract all the frequency data of the syntax and how many times each library is used, then create a graph. So a graph of maybe a graph or a list of the importance order based on the frequency of which ones to study first. Then once I have that, I go over the library with the debugger, stepping through it, and then I manually write a bunch of questions and ask ChatGPT. Then after I do these questions, the thing that I realize is that the most important things are probably data structures, then transformations, and then the resolution of types and traits, and the relationship between types, the covariance, contravariance, and invariance. It's very confusing. And then the other one is the relationship between libraries, because for example, for all the programs you have, you're always going to need, not you're always going to need, but most of the time you're going to need something to parse the arguments. So you're going to use a library for that, and then that library is going to be related to other libraries. So like this kind of mechanics. So I need to manually build exercises based on the patterns that are used the most, and the ones that I have questions about after studying the libraries. I was gonna ask, yeah, where? Hey, what's up? I'm building a system to improve at Rust. The idea that I have is kind of like build a gym that I want to basically have a ritual that I can do like anywhere between half an hour and 1 hour a day. It doesn't take time to think about, and I just do it every day so that every time I'm becoming better at like things that I use all the time. Like the goal is to decrease the friction between the intent that I have and the execution. But now I'm spending more time than I want. So I think that's hopefully the way that it's gonna go is I'm gonna spend a lot of time now in the beginning to build the system. But then once the system is done, I can just make like a ritual and then I can focus on other stuff. But the idea that I arrived at is to first build a project that goes over a bunch of Rust libraries and then extract patterns that are used the most, and then create a dependency graph of these patterns or the libraries that I use. A dependency graph of the libraries that are used the most, and then create another like a bunch of other reports with the patterns that are used the most. Then use that to organize like the order of importance to do each thing. Then I'm gonna go over probably with the debugger on VS Code on which library, or like based on the library that is used the most. I'm gonna start with that one, go over with the debugger on that one, then manually ask write questions, and then like try to manually see the patterns. And once I do that, I start building exercises manually as well, based on the patterns that are used the most. And the goal of the exercise is gonna be to basically memorize, but also understand like what things I have to do most of the time. Then hopefully, eventually, I'm not gonna have to look into documentation or talk to LLMs to write everything. Oh, nice. Yeah, I wanted to study the compiler, but this is the first day that I was doing this, which was yesterday that I started this kind of project. My initial idea before that was to study Rust compiler, which is Rust C. But the issue is that there's too many files and kind of hard to like know what thing matters the most to study. That was the problem that I had there. That's the reason why I decided to go this other route. And this is an issue usually when it's like going over with the debugger, you get into those loops and repeating patterns, and then it gets annoying to go over. I think I'm gonna try to put a breakpoint somewhere else there. Just keep this. I got stuck on the small things. Hmm. As I think I already get what this is doing. I think that this is the stack here. I already get what this function is doing. It's basically going over all the cargo tone files from the main folder. So this one discovers the cargo tones, then puts them on a vector probably. Then this one maps and then parses the cargo using this TOML library, I think. Yeah, it reads the file, then uses this TOM to parse. and resolves membership. I think that is not worth it to spend time. I should probably just look into the main functions and get a rough idea of what they're doing. Then continue to build as GPT for prompts to send to DeepSeek. Then to finish building so that I extract all the patterns. And once everything is complete, maybe I'll spend more time looking into this. But I also think that's probably not worth it. It's better to get this done and then spend time studying the actual libraries instead. So once I have the reports, one thing that I might ask to ask GPT to put on the prompt is so that DeepSeek creates a easier to understand, because I think these files are probably good to send to LLMs, but not to read myself. So I need like a final formatted markdown file, with the like direct order in checklist probably, and then I use that to determine how I'm gonna study each library. It's gonna do everything and then it's gonna get the report here. This was being run here. Gonna put a breakpoint here. Now I'm gonna have to remove this one, I think. I probably remove this one as well. I think it's just gonna get stuck on the. It's gonna have to go over all of them. If I don't remove, it's gonna get stuck on the loop. Okay. It puts all the analysis on this thing here. It's a binary tree map. It has a name, manifest, forward, transfer. Okay. So it sorts. Whatever. I think I already get it. The hardest parts yeah, the hardest parts are done by the other libraries that uses to parse the TOML file. It's good to know that there are libraries like that, so maybe I can use them in the future. So just gonna sort them, then transform the data to this stats thing here, and then returns based on the stats, the census result. And it's probably gonna use that to write the files, the reports on the folder. Yeah, create all there. Then write file. Okay, so I'm probably gonna ask GPT now what to prompt. I'm gonna send the information that I have there on the other thing. This part's probably like as I go over the libraries later after I'm done with this phase one here. Probably gonna be interesting to actually share the assembly with ChatGPT and then ask what it thinks about it. And this syntax here, I think, is 80. I'm not really sure if it's AT&T syntax, something like that, or AST or something like that. I think that's what the syntax is when you have this percentage before the register name. Whenever you have this, then you're gonna read from left to right, as far as I remember. But the default one, the one used the most by assembly, I think, is you read from right to left. For example, when you're moving the value on the register on the right to the value on the register on the left. But I think here is the opposite. So this instruction, for example, you would move the value on the RA register to the RS one, if I remember correctly. And I think that probably the reason why the debugger shows both assembly and Rust is because of the intermediate representation thing on Rust. So I think the compiler, there's some situations where the compiler doesn't, like it adds more instructions on the intermediate representation, I think, that don't exist on the actual source. So the debugger becomes the assembly, I think, instructions. Yeah, okay. So yeah. I think that there for the manual exercises that I build later, we should probably. It's kind of hard to think. I think I'm gonna have to spend more time thinking about it with discussing with GPT as well. It's kind of hard to think about something that resets the. Like I can obviously manually erase after I'm done. Maybe that's the best thing to do. But it becomes kind of awkward. It's basically the same thing that I have on the other thing already on the training fundamentals, which is the Rust training thing. That I have one folder with the exercises and the other one with the solutions. And then I think I did some script, some PowerShell script based on the GitHub versions to make it so that I can erase or go back to the beginning after I'm done with the exercise. But it is kind of awkward to do this, I think. So maybe there's a better way. That's the reason why I gravitated towards building for the website using closed cards. Because then obviously it's a lot easier on the website to just fill up the gaps on the closed card. So like I can have an algorithm, then I automatically select parts of the algorithm to erase or to replace with fields. I think it's fields the way you say it, or like the form thing to write to complete the partial implementation, and then submit based on that. That seems easier to do, but then the issue with that one is that I'm not really sure. I think it's gonna become like more a memorization type of thing. I think for the closed cards, it's probably better to do it for methods I wanna memorize for the string, for example, and vector methods and other stuff like this. But to actually understand, I think the manual exercise is probably better to do based on transformations and also testing. Like if I create two different traits, if I create two different traits with different generics, and then I create an implementation for them, then what happens on runtime? Like how the compiler figures out which thing to use. I think these types of things are good to do manual exercises on, and also to the main question, the hardest question to figure out is not how to do something, but what is the best way to do it. Because usually you get into a situation where you have a bunch of different ways to do the same thing, and the best way to do it depends on what you're actually trying to do. So there isn't it depends on the constraints of what you're doing. There isn't an absolute solution. So because of that, I think I need to think about a way to manually write like some exercise that allows me to figure out how to think about building things from scratch instead of just looking from the other libraries. The thing that I'm struggling the most is I can look into a library and see that they implemented a struct using a generic type, and then we have all these functions, and it's very easy to understand. But then when I'm thinking about building from scratch, I almost never think about like using generics and these types of things. And I'm not really sure why. I'm not sure if I think it's both because it's a property of libraries having to be designed to be used by a bunch of different people, so it kind of forces you to use more generics. But I also think it's a property of habit as well. It might be like habit. So how do I solve that? That's the hard part.
Yes, I would keep almost exactly the flow you proposed, with one guardrail. Use the debugger to trace selected execution paths, not to read the whole library dynamically. That gives you a very strong workflow. Since it's downward arrow what matters what recurs dependency relationships, downward arrow library tracing build run real library paths under code LDB, downward arrow notes about transformations, representations, types, APIs, downward arrow manual labs reproduce. The high value patterns yourself, downward arrow rest forge extract facts that are primarily memorization. I think this is better than starting the manual exercises immediately. The debugger should become a major study tool for each library. Don't just hit F11 repeatedly from main. Before debugging, choose a question such as candle, how does tensor reshape ultimately change? Representation, CPAL, what happens from building a string to the audio callback? Rayon, what happens when PAR underscore map? Collect executes. Certi, what happens from certi underscore JSON from underscore str to writing struct fields? Clap, how does ARGB become ARG struct? Then identify maybe 3 to 5 functions along that path and place breakpoints there. Your session becomes user facing operation, downward arrow public API, downward arrow important abstraction, downward arrow core representation, downward arrow interesting primitive stop when you've answered the question. Assembly is useful, but demand driven the fact code LDB can eventually expose assembly is excellent. But don't descend like Rust, downward arrow split, downward arrow allocator, downward arrow CRT, downward arrow assembly, downward arrow where am I? Instead, question, does this iterator abstraction disappear? Debug inspect source, downward arrow specific generated operation interests me, downward arrow look at assembly should answer a specific question. Did this generic dispatch disappear? Was this function inlined? Did bounce checking remain? Did this loop vectorize? Is this copy actually empty? What does this enum representation become? Then it has very high signal. One important modification to the library study process: don't necessarily debug the first 5 libraries in the current handwritten order. Finish census first. Then use frequency dependency graph position relevance to your goals conceptual leverage to choose the first 5. For example, I wouldn't be surprised if we ended up with something approximately like certain clap rayon candle wasn't mentioned or perhaps certain Tokyo futures rayon candle, but we shouldn't decide that yet. That's precisely what census is supposed to help determine. Where does TOML come from? This is an important Rust detail. Inside manifest R's, you have code such as Rust let value, TOML value, TOML from underscore str content, map underscore. The attached implementation directly uses TOML value and TOML from underscore str. But there's no Rust use TOML and no Rust extern crate as TOML. That's normal modern Rust. If tool census cargo.toml contains something like TOML dependencies TOML, then cargo passes the crate to Rust, and Rust makes the crate name available through the extern prelude. So you can directly write Rust TOML value just like Rust 30 serialized walk dir you only need use when you want to bring something further into the local namespace. For example, Rust use TOML value allows Rust lets value instead of Rust lets TOML value. Think of it as two namespaces. Cargo says this crate depends on TOML. Then Rust knows TOML exists. A use declaration is more like inside this module, give me a shorter local path to something. So Rust use TOML value is not what loads the dependency. Cargo.toml does that. Use just changes name resolution convenience. And because we previously had the agent add PowerShell cargo.toml, you should find it in Rust Fluency Lab tool census. Cargo.toml uploaded files don't include the cargo manifest, so I can't quote its exact version. But if the current project compiles, TOML must be available as a direct census dependency or inherited workspace. Dependency. Rust code cannot normally access arbitrary transitive dependencies just because another dependency uses them. This is already a perfect example of something that should eventually become a forged recall card. Question: why can TOML value be referenced without use TOML? Concept: extern prelude cargo dependency resolution. What I think census still needs before census v2. I would make v1.1. There are three things I would fix. One, docs shouldn't affect the denominator. Currently census reports 57 repositories, but docs has 0 manifests and 0 packages. Keep it in inventory if useful, but don't let it affect repositories using sturdy only Rust repositories actually participating in the census should be in that denominator. Two separate internal workspace crates for ecosystem dependencies. Currently Crane reports dependencies like Crane Core alongside real external dependencies such as Candle Core Sturdy Tokyo Tokenizer Symphonia. Likewise contains lots of its own Symphonia crates. Those are useful, but they're a different measurement. We want external ecosystem edges Crane rightward arrow Sturdy Crane rightward arrow Candle Crane rightward arrow Tokyo versus internal architecture. Edges Crane rightward arrow Crane Core Symphonia rightward arrow Symphonia Core. Keep both. Do not mix them. 3 tighten the definition of standalone nested package. I noticed one subtle issue in membership. Ours. The current rule explicitly says a package with no owning workspace root is a standalone package, and the implementation counts it. For ordinary repositories that's reasonable. For monstrous repositories like Rust, this can accidentally count test fixtures examples experiments nested support projects as real components simply because they're not under a workspace. That's exactly what we originally wanted to avoid. So I changed the policy. If repo has a root workspace, count explicit workspace members nested workspace, count its explicit members. Standalone root cargo package, count it random nested package outside every workspace. Inventory it, but do not count by default. That's more conservative. I agree completely about a final human readable report. The existing reports are good machine/research outputs, but you need a dashboard document. Eventually I want generated summary.md that starts something like Rust corpus summary corpus 56 Rust repositories 1210 workspace packages. Most common runtime dependencies 1. Sturdy 38 repos 67.92. Clap 20 repos 35.73. Anyhow. Most common development libraries 1. Criterion 2. Temp file 3. Prop test. Common library bundle sturdy underscore JSON quote DROC macro 2 Tokyo futures was a JS web SYS. Corpus dependency graph most connected. Most frequent built-in types 1. Vec 2. Option 3. Result. Most frequent methods 1. 2. Most frequent traits. Most frequent language constructs. Recommended study order. That becomes the document you actually read. All the JSON and giant tables support it. Dependency graphs are absolutely worth adding. This is another thing I'd add before source scanning. There are two graphs I particularly care about. Corpus graph only relationships among repositories you're studying. Crane Candle Tokenizers root .org.io CPA FT Rust FT. This helps determine traversal order. If many things depend on a library, that's evidence it may be useful to study earlier. Co-occurrence graph. This one could be even more interesting. Sturdy underscore JSON clap this arrow Tokyo futures tracing was a JS web SYS wait number of repositories where both occur. Now we begin discovering standard Rust architecture bundles empirically. That's exactly the CLI/wiring thing you've been describing. Then census v2 scans source patterns once v1.1 is clean. v2 asks, what do programmers actually write? Generate at least types underscore frequency methods underscore frequency traits underscore frequency macros underscore frequency language underscore constructs underscore frequency generic underscore constructs underscore frequency ownership underscore constructs underscore frequency and maintain the same fundamental measurements. Repository frequency leftward arrow primary raw occurrences leftward arrow secondary files containing leftward arrow useful so it said. Use it map 90,000 times. It still only gets one repository vote toward ubiquity. I would therefore send DeepSeek this next. This should be census v1.1 only. Don't mix source parsing into the same implementation pass. Make the measurement foundation correct first. Continue work on Rust Fluency Lab tool census. This is census v1.1. Do not implement Rust source/syntax scanning yet. The goal is to make the dependency census trustworthy and produce one concise human readable summary before census v2 is added. Do not modify libraries underscore study. Rust Forge Gym or the manual lab crates.1. Correct the repository denominator. The corpus currently includes directories such as docs with 0 cargo manifest/packages. Keep all immediate child directories visible in inventory if useful, but introduce a distinction between discovered corpus directories Rust repositories participating in dependency. Frequency statistics. A repository should participate in dependency percentages only when it contains at least one counted cargo package. Reports must clearly state both numbers, but dependency percentages must use the participating Rust repository count as the denominator. Two separate external dependencies from repository internal crates extend manifest parsing so every counted package records its actual package. Name for each top level repository. Build a set of package names belonging to that repository. Classify dependency edges into external ecosystem dependency internal same repository dependency. Example of package Crane depends on Crane Core. That is internal, but if package Crane depends on Sturdy, Candle Core, or Tokyo, those are external unless those package names belong to the same top level repository. Do not remove internal dependency information. Report it separately, but the primary ecosystem dependency ranking must contain external dependencies only. 3 tighten standalone nested package handling the current resolver counts any package without owning workspace as a standalone package. This is too permissive for giant repositories containing fixtures/examples/support projects. Change the conservative policy to root package at the top level repository root. Count explicit workspace members. Count the root package of an explicitly discovered nested workspace. Count explicit members of nested workspaces. Count the arbitrary nested package manifests that belong to no explicit workspace. Inventory them as unknown underscore nested underscore packages, but do not include them in dependency aggregation by default. Add tests for this behavior, but do not silently discard these manifests. Make them visible in repository diagnostics. For resolve inherited renamed workspace dependencies correctly, support cases like workspace dependencies foo package actual package version 1 combined with member dependencies foo. Workspace true dependency statistics should use actual package, not foo, to preserve the local alias as metadata where useful. Add unit tests. 5. Produce separate external dependency rankings. Generate external underscore runtime underscore dependencies. Normal /runtime dependency usage. Generate external underscore dev underscore dependencies. Def dependencies. Generate external underscore build underscore dependencies. Build dependencies. Generate external underscore dependency underscore frequency. Combine external dependency ranking. Keep the existing JSON outputs updated with internal/external. Classification of each ranking should primarily sort by independent participating repository frequency. 6. Produce internal architecture information. Generate internal underscore workspace underscore. After this, don't start library debugging yet. Send me the new summary.md, corpus dependency graph, and top dependency reports. Then we'll write the census v2 prompt for source scanning. After v2, we'll finally have both ecosystem, which libraries recur, language, which types, methods, traits, transformations recur. At that point, we can create an evidence-based library traversal order. Choose the first 5 libraries, and for each one define the exact executable/example/test. Path you should run under code LLVD rather than wandering through the repository arbitrarily. That is where I think the process will become extremely powerful. Static census tells you where to look. Debugger tracing tells you what actually happens. Manual reimplementation tells you whether it became yours.
The other thing that I was thinking about is to do something like this, but for Rust. Which basically, because this is another thing that is kind of always confusing or is somewhat of a black box, is what happens on memory as Rust is executing. So I could do something like this for my website. But I'm going to stop here. I'm going to continue to build the census of string. Then probably next time I'm going to go over with the debugger on some libraries, or maybe start building my manual exercises depending on how far I go upstream. So see you then.